I know I said that I wasn't going to remove the light pipe from in here, but after having a very heartfelt one-on-one talk with myself and pepping myself up to do it for science, I finally came to the conclusion that, okay, I'll remove it. Actually, the biggest reason why I decided I could remove it is because these screws here, there's two of them. There's one back here and this one right here. It's very easy to readjust as if I want to get the alignment right on that thing. And I'll show you guys in a minute what I mean. But yeah, so it's really not a big deal. So what I'm going to do is I'm going to... Oh, that spring is really tight. Okay, I'm going to have to like probably back this up a little bit to loosen up that spring there. So the reason why I found out that this isn't hard to adjust, I've put a piece of white paper right there in the back where the DMD would normally be. And if we shine a flashlight into the side here, we see that we get our little white rectangle there. Okay, hope the paper doesn't fall. And now if you carefully watch here, I'm going to put a screwdriver into this screw here, and I'm going to turn it clockwise at first. And you can see that that rectangle there is shifting down. If I turn it counterclockwise, it starts shifting up. And then the one back here, that screw, it's not, you can't get to it as is right now because there's actually like a little label up here at the top that's blocking the hole that gives you access to that screw. But then that one's basically going to be like left and right adjustment for that. So yeah, adjusting this is really not going to be a big deal. Okay, so now the two screws, the ones that was here and then the one that was here, are both out now. I should just be able to lift this up. Actually, it looks like I didn't even need to remove that spring. But let's see. Aha, there it is. There's a much better close-up look of it. And as you can see, there are mirrors glued to the outside of it. So basically they are using internal reflection there to like help disperse the light a little bit so that you don't get like a concentrated hot spot like right in the center. So that would kind of help make the light output a little bit more even, I would think, so that like part of your image doesn't have like, you know, really bright colors and then another one looks kind of like darker or whatever. And it turns out that I didn't even need to remove this spring the way it's all kind of mounted here. There's a little screw here in the back that mounts this whole like entire frame to this outer frame here. So me backing off this screw was completely pointless also. But like I said, it's not going to be a big deal to readjust this to kind of get the light to shine on the micromirror device. So initially I thought that this little light pipe, you know, that they were just relying on like the internal reflection of the actual crystal itself. I didn't actually think that there was going to be like mirrors strapped to the outside of it like that. The clarity on this stuff is like so ridiculous. Look, you can read this capacitor all the way from the other side of it. It's like there's nothing even there. That's just wild. And you can kind of see how it's basically those mirrors inside basically acting like a kaleidoscope, and they're, well, kind of like giving that sort of effect. Tubular. There's kind of no point in taking these prisms out because you can basically see what they are. They're just like one of their faces. The slanted side is, you know, they're facing each other and it's basically just kind of like forming a square. But there are a few other lenses in here. So let's see if we can remove this without dropping anything. Okay, there it is. So this one here looks like it's got a flat side, or it's yeah, it looks like that side here is completely flat, and then this side is convex. This one here has a convex side. Let me move this out of the way so maybe we can get this a little more in focus. Okay, so it looks like what might be happening here is these two lenses take that rectangular light output from here, and probably it looks like it might be focusing it into like a very, very tiny rectangle on the surface mirror that would be here, which is it's still inside the case. And then this lens here takes care of magnifying that a little bit so that it fits the area on the surface of the digital micromirror device. And then from there, you really don't want the light, you know, like spreading very much more. You want it to go straight out, so you want to keep it probably as concentrated as possible just to that little rectangular area. But then the rest of the projection assembly is what takes care of like blowing up the image produced from there outwards. I was trying to think of a good way to possibly, you know, be able to see how these lenses focus the light. Let me think of something real quick. Okay, so here's what we're gonna do. So I've got this laser that I removed the focusing lens from, so that way I can get a little bit more of a spread on the light there. And what I'm going to do is this. I'm going to mount using one of these little holder things. I'm going to clamp it here. I'm going to shine the light into this lens, so it's going to sit like back here. And then I'm going to take this rolled up piece of toilet paper soaked in ethylene glycol, wrapped in copper wire. I'm going to hook it up to some voltage here, like 12 volts, and hopefully it'll produce enough vapor so that we can kind of flood this area here, and you can see how the light, you know, kind of goes through these lenses and how it gets focused over on this side. So that's the idea, at least. Is it going to work? I'm not entirely sure, but we're doing it for science, and anything's okay as long as you're doing it for science, right? Okay, we're about to fire this up here. So I've got the lens or the laser there situated. I think this should be like in a pretty good spot there, like that. Okay, so what we're hoping to see here is hopefully we'll be able to see the light beam and how it gets, like, you know, focused over into this area here where my finger is there. I've got the roll here set on top of a piece of cardboard because if it wasn't flammable enough already, now it certainly should be. Not that I want any flames or anything, but I would just rather avoid burning the thing. And I don't want to set it on metal because then we're just going to be potentially shorting those coils. So I'm not going to hook this up to 12 volts and leave it there directly. I'm just going to, like, maybe, you know, kind of pulse it like on and off just so it doesn't completely combust or anything like that. So now I'm going to turn off this light. I'm going to focus, oops, wrong way. I'm going to focus in on that lens there. There we go. Okay, hopefully that should be good enough. Alright, I'm turning on the power supply, and I'm going to touch the 12 volt connection here to power. Let's see. Hey, you can hear me overloading the supply there. And it's generating some fumes, but not enough, and not where I actually want them to go. Come on. Ah, there we go. I have to blow the fumes kind of under there. You can kind of see it. Alright, I moved the coil in just a little bit closer. And let's see if this makes any difference here. That's probably as good as it's going to get right there. But yeah, you can see how the little intense beam is getting focused right in this area. So that's where that mirror would be. So then this lens up here takes care of magnifying it even more. Yeah, that didn't work as great as I was hoping. But you kind of get the idea, I think. Well, and since we're playing with fire now, the pyro in me wants to see how much we can get this thing to smoke. So let's just push it till it pops. Ready? And fire. Oh, that's dumb. Stupid current limiting. Alright, well, that was pretty disappointing, but I think we kind of got the idea. So anyways, I've already put these back on. These lenses are all back in place. I'm going to reattach the little pipe here, and I'm going to put the color wheel back on because there's another thing I want to show here. Okay, so I've got the pipe back on. I put the color wheel back on. I put that white piece of paper back there, but I have it held in place right now with the DMD itself. I just kind of put 2 screws on here just to hold this whole board in place there. So, unlike an LCD set or an LCD projection set where you have 3 individual LCDs, you know, one doing each red, green, and blue, with this DLP here, if you're not too familiar with it, we only have the single DMD there producing everything, but the digital micromirror device itself doesn't actually produce any colors. It's just you know, like a huge array of like microscopic mirrors bouncing the light. So as the color wheel, you know, the term there would suggest, is what actually produces our colors. So if we say move this index all the way to the bottom there, and then we take a light and we shine it through that window there is our color. So we have green, and as we turn this wheel, if we turn it clockwise, next color we hit is blue, and then red. So basically what you are actually seeing anytime you're looking at the screen is you're not seeing, you know, like whole colors. Like you're not seeing purple, you're not seeing yellow. You're just seeing red, green, and blue, just alternating like very, very quickly. So if I actually turn this like really fast, it'll look like just white light. But yeah, in reality, you're just seeing red, green, and blue like super fast. Actually, I got a better angle on there now so you can see it. So red, green, blue, red, green, blue. And there are some wheels that I have seen in the past that had more than 3 colors. Like it had, I think it also had like cyan, magenta, and yellow, along with a clear window, so that it would just be like red, green, and blue, cyan, yellow, magenta, and then clear. I'm not sure if those are the types that are actually used in like the 3DLP assemblies. I've seen them, but I don't know what they actually came from. But yep, that's how we get color. So now I was actually thinking, since we've made a delightful mess out of a bunch of components here, maybe we should put everything back together and we'll look at the picture coming off directly off the DMD there, assuming I haven't like killed anything in the process already. So yeah, let's do that. Okay, well, it's major disappointment time again. As you can see here, I've got pretty much everything connected together, put back together just enough to, you know, try to make everything function, with the exception of the ballast, because I somehow managed to apparently bork the ballast. I'm not entirely sure what happened, but I did manage to get things to power up one time only without the lamp connected. But then when I went to reconnect the lamp to try to, you know, do whatever we were going to do here with some testing, because obviously the system's not going to work without the lamp functioning. When I went to do that, I couldn't get it to do anything again. At one point I did manage to get the lamp to fire up by just manually shorting some of these output couplers here. But that was about it. After that, I couldn't even get the lamp to strike anymore. So whatever the problem is, I'm pretty sure it's isolated like here on this ballast board. I don't think I damaged anything on the DLP projector, because the only connection that goes to the lamp ballast board here is this, and this is all completely like opto isolated with these right here. So there's no electrical connections going from there to here. Nothing direct. There is some electrical connections like right here, but that's going to the microcontroller, and I don't think that's the issue, because it still knows whether or not the lamp door is plugged in or not, or open. As I was trying to demo also that it puts out some audio prompts, and I'll play like the little sample there of when it detects that the lamp door is open.
Lamp door is open.
So that stuff was working, but I can't get this to come back on or do anything at all. So that's, yeah, unfortunately not going to be able to do any testing or measurements on any of this stuff here how I was hoping. But if I can somehow get this ballast board to work at some point in the future, then I might, you know, do a video on all that stuff. But for the time being, I'm just going to leave all that out, because I spent hours trying to get this thing to fire back up and work, and I just cannot get it to do anything at all. So I figured there's no point in wasting your time with all that. So anyways, what I was going to do, just briefly, is I was going to power it up without the lamp in the shot. You know, I was going to leave the lamp separate, and I was going to shine a flashlight into the little window so we could see, you know, an image being formed on the DMD itself. However, not only did I manage to screw up the ballast board, I also blew up the batteries inside of this flashlight, which was this right here, or at least that's what it used to be. It was 3 little nickel metal hydride rechargeable batteries inside of that thing. So what happened was I was trying to charge the batteries externally, like outside of the flashlight. This is meant to go like in a cigarette lighter socket. I took everything out at the moment, but so basically it goes in a cigarette lighter socket. You leave it in your car, it charges. Well, I don't have a socket around here anywhere, and my, you know, our vehicles, they turn off the socket when you're not in the you know, when you have the key on, so it was kind of pointless to try to even, you know, charge it somewhere out there. So I was trying to charge it externally using an automatic battery charger. Well, little did I realize that it was set to charge a 7.2 volt battery pack, not a 3.6, which is what these little ones are. And so a few seconds, actually it wasn't even a few seconds later, it was like a few minutes later, when I went to go check on it, I just got a pop pop because 2 of the batteries exploded. Oh well. Well, anyways, I had this other one here that this one does work. So, but I don't think it's as bright as that other one I was planning on using. So we're just gonna, I was just gonna shine this into the window, so at least we weren't getting like too much of a bright light with the lamp. But yeah, that's not gonna happen anymore either. So, oh well. I guess the only thing left to do now is just to compare the optics inside of this with the ones from the LCD and the LCOS projectors. Because other than that, I can't do anything unless I can get this thing to power up. So, sorry about that, guys. Just removing the cover that sits up here over all the optics, you can see how much more complicated this LCD projector is already. So, we start over here on this side, and as we can see, that's where our lamp is. We go through a lens here that is kind of sitting at an angle. I'm not sure exactly what the purpose of that is, but they have sort of like they have some slots here on this side, so it looks like there might have been another lens that would have sat here, but this one didn't have it. So yeah, I don't know what that's all about. So this little lens here looks like it's slightly concave on both sides. It's really hard to tell, but it's just got like a slight little bit of concavity on both sides. So right after that, I think this would be for helping the light kind of spread out like a little bit, because the light coming from the lamp here would probably be a little bit, kind of concentrating like sort of like inwards, like it would be focused to kind of go in. But then this one here would kind of make it spread out just a tiny bit, and it would hit this lens here, which is a fly eye lens. And I was kind of hoping that I would be able to pull some of these out easily, but it doesn't look like they're pretty pressure fit in there. So anyways, right after that, it goes through this assembly here, and I'll get a better shot of this in a second here. This actually has it's like a little mechanical shutter. And it's actually got a pretty interesting shape to it, so I'll show you what that looks like in a bit. And so after it goes through that, it goes through this other set of lenses here, which actually look more like it's some sort of a spreader, like it spreads the light kind of like in a bunch of different directions. It's not really a lens per se that I can tell. It kind of looks like it might be sort of like a fly eye lens with this sort of like weird spreading system to it. So we'll get a better look at that. And basically, like all this like spreading the light, all what that's doing, and this fly eye lens here is just getting so that there's not like a bright spot of light hitting any of these LCDs over here, because these three right here, these would be our LCDs. Like, so we'd have one for blue, one for green, or one for red, and then one for green over here. So we don't want to have like any bright spots anywhere along the line. So that's what these take care of doing. Right after that, it goes through another lens, which is right underneath this right here. And this is glued in place, so it'd be really hard to remove. And that's a convex lens on both sides, so that would probably be helping like keep the light, sort of parallel. And it bounces off of this mirror, and it's a filter here. This is what's called a dichroic mirror. So it bounces off certain wavelength of light for blue to go off in this direction. Right here on this side we have a surface mirror that goes into this lens right here. There's another little convex lens, and then that goes through the LCD. After it exits the LCD, there is a set of 4 prisms right here arranged in a square. So that takes care of taking the light from this LCD and basically bounces this off of an internal mirror right here and out into the projector, or the projection lens assembly, which just starts right at this point right here. So that right at that point would basically be the same as the input lens on this other assembly here that we saw in the DLP. So we're kind of going to ignore from this point on, because from there, on it's pretty similar stuff. And I'm basically just trying to compare like the internals here. So this dichroic mirror allows the blue light to go off in this direction, but it allows the green and red wavelengths to kind of go off in this direction. Right here at this point we have another dichroic mirror, so this one bounces off the red light going off in this direction and lets the green light through. We hit another convex lens right here, we hit another surface mirror, and all this stuff here, basically what it's doing is just keeping the light from either spreading too much or focusing at one point. So bounces off this mirror, goes through another convex lens, bounces off another surface mirror, and then it goes through another it's both a lens and a mirror at the same time. It's a little convex lens, but it also has another, not a mirror, a filter. It has like a dichroic filter on it. I don't think the blue one over here has one, although it might. I haven't taken it off yet, but I know for sure this green one does. Actually, it looks like the red one does too. So I'll pop one of those out and we can take a look at it. So basically, you can see that it just gets really complicated. I'm going to turn off this light. I'm going to remove this lamp. And it would be nice if I could form some vapor here so that, you know, we could see how all the light kind of goes through here. But I'm going to take this flashlight and I'm going to shine it in on this side. So there, let me get something white, like a piece of paper. So we can see that the light coming out of this right here is just basically white light. But then on this side, everything that reflects from there is just blue light. That's because of this filter here and mirror. If we go to this side, we see that it's kind of yellowish looking. But then once it bounces off of this filter here, now we have red. And on this side, we have just basically, it looks like a really kind of a lime green. And then it goes through this lens here, it goes through this other lens here. And then once it goes through the, you know, to the very last filter there, then it, you know, gets turned into whatever, or basically gets filtered to, you know, the wavelength we need. So if we zoom in right into the center here, we can see how that one there is just red, that one's just blue, and that one there is just green. So this lens here already came out at one point. It wasn't even on purpose, it just kind of got pulled up when I removed the cover there. But so that's what that looks like. And it looks like it's red, but it's really like a, oh, this is going to be kind of hard to do, but really it's just like a green filter. So yeah, it's going to be kind of blown out here, but it's, yeah, basically it only allows the green light through. And you can see it's convex lens on one side, and then the filter's attached to the surface on this side. So then it's kind of hard to see here, but if I kind of shine the light just around, you can see how there's 4 prisms in that block right there in the center. Yeah, it's kind of hard to do, but let me see. I mean, I can kind of see it here. It might be harder to see. Oh, you can kind of tell right there. Well, you can tell how there's like a prism here, there's a prism here, and then another prism right here. So yeah, all those are kind of working together to combine the light output into one solid image that then gets projected outwards. Now here's that shutter assembly I was talking about. There is an actuator over here on the side that takes care of opening and closing this, and makes a little window right there, right in the center. I'm guessing that's just for maybe making a dark scene darker, kind of how that dynamic black assembly worked in the DLP projector. I'm guessing this is probably something pretty similar to that, except that instead of being on the output side of the projector, or like, you know, right before the, or right in between the, you know, some of the sections of the actual projection lens, this one's like right before it gets to the whole light splitters and everything there, and the filters and all that stuff. Jeez, there's a bunch of like dust buildup and stuff inside here too, so it's all pretty nasty on the inside too. And it might be, I don't know how easy it's going to be to tell, but you can tell how the lamp has damaged the material on here as well, kind of like it did on the connector on the DLP lamp assembly that we saw there. But yeah, so this stuff right here is just like flaking off. This looks like it's sort of like a fiberglass reinforced material, like a sort of like a plastic, but yeah, it's just nice and flaky now. One more thing on this LCD projector, the blue one, the blue LCD actually has this little polarizer. I don't know what that's all about. It looks, the red one and the green one over here, they also have provisions to have one installed, but they don't have one. Only the blue one does. So I don't know what that's all about. Here's a close-up of that lens I was just talking about. You can see how there's like various crystals that are kind of like adhered together, and some of these are going off in this direction. This one right here, they look more triangular, kind of like a prism, and then there's the ones over here on this side going off in this direction. So yeah, it's kind of weird, but you can tell that it's not one. If I remove this right here, you can see how there's another set of lenses right here, and this one right here is the one that looks like more like a fly eye lens. So both of these are pretty much like glued back to back. On the underside of the cover for the light engine, we can see that they have these leaf springs right here to keep some tension on those lenses that are kind of all over the place here. You don't want those, like, you know, shifting around with vibrations or anything, so it doesn't like distort the image. And then over here they have some sort of like foamy sponge things to keep some pressure on those dichroic lenses that they have there. I'm trying to get this one opened up here so we can take a look at it, but you'd think with all this copper shielding here, this thing was meant to go out into space or something. Okay, we're in. So right off the bat, we can see that there's a bit of similarity between this one and the LCD, and as the name LCOS would kind of suggest, this works a lot like an LCD. That's you know, liquid crystal on silicon. So on this one here, our lamp would be sitting in this little cavity here, and there's a little window right here that looks maybe like it might be like a UV filter of sorts. And then we go and we hit this surface mirror. Surface mirror bounces the light into this fly eye lens right here. And then we have another similar assembly like we saw on the LCD projector, where it looks like it's just I don't even know what this kind of lens is called. I tried to look it up, but I can't really find a name. It's some sort of a spreading lens to spread the light like random, so you don't get like that bright spot. So there's another fly eye looking lens right behind it too. So it hits that. Right here we have another convex lens, and then on the opposite side we have another convex lens. This right here is nothing. That's just it's like a solid metal window. It's just got an opening on that side. Right in here, before we hit this first prism, there is I'm not even sure what it is, but it's burnt. It looks like it's it was supposed to be some sort of a filter or something, but it's got a big hole burnt in through the middle of it. I'll show you guys a better view of it in a bit. So after we hit this first prism, this here is 2 prisms. We hit 2 smaller prisms right here in these areas, and then there's another set of 2 prisms right here, and then this is our output for the projection lens. So from this point on, you know, it's basically the same as the other lenses that we already saw. So all the magic happens in this little area right here. So if we shine our light, we can see that up to this point here, you know, there's no filtering. It's just nothing but white light. So after we go into here, this is where we have our dichroic mirrors. They're probably part of these prisms right here. I don't know if we're going to be able to see much unless I maybe put the light on this side. Alright, so we're going to zoom into this area here for now. Actually, I want to show you that burnt thing first. Okay, right in there. I removed the lens that was up here in the front so you can actually see through it better. But you can see that it looks like the light gets focused so intensely in that spot there that this thing has just been like completely crispified. It's flakier than a Hot Pocket. So I don't know if that's due to maybe like dust accumulation on here. You know, starts getting hot and it starts burning, and then it just kind of just snowballs from there. Or if this over time just, you know, can't handle the heat anymore, it starts discoloring itself and then it just burns up. Because this stuff here, even though it's sort of somewhat shielded, I mean, dust still builds up in here. Deep, like inside over here in this part, there's quite a bit of dust buildup. So I wouldn't doubt it that a little bit of dust on there, you know, would start burning up, and then that's what would cause that thing to just completely fail over time. The thing is, though, that even though it's all burnt right here, you really don't see anything in the output image, because this TV, when it was still kind of all put together, you couldn't tell that there was anything wrong with that image. So it appears that this here is just a filter of sorts, maybe just for, you know, some additional protection against UV hitting the actual like LCOS little elements here, maybe to, you know, prevent damaging them like prematurely. But yeah, that's completely gone now. I'm going to turn off this light, and I'm going to take the flashlight and put it in over here and see if we can, you know, see which these assemblies is which color. Okay, so I got the light here, and there we go. So we can see that the one up here towards the top right, that one there would be the blue, and these 2 other ones are kind of hard to see, but it looks like the one on the bottom left there is the green one, and then the one to the very left over there, that is the red one. So I kind of drew up a little diagram here of how the light actually travels inside of this thing, and I'll show you guys that in a second here. But basically, we can tell that unlike the LCD projector, where the light actually has to go through the LCD itself, these LCOS ones here, they're on the edge, or they're on the outside edge of those prisms. So what they're doing is they're taking this light for example, let's say the green one. So the light goes through here. This area right here is probably going to be one of those dichroic prisms. It's going to bounce the light internally, reflect off into this direction. It hits the LCOS right here, and then the light bounces off, goes off in this direction, and then just goes straight out. So that would be for the green. For the red one, the light goes straight through, hits the filter right here, goes straight through, hits the red LCOS assembly, bounces off, hits the internal reflection of that prism, bounces off into this direction and out the projection lens. So for the blue one, we come in here, bounces off here, goes into this direction. This is where we'd have our dichroic prism, bounces off the LCOS right there, comes straight out in this direction, bounces off this prism and out the projection lens. Alright, here now we have some crude diagrams showing how the light output from the lamp basically gets turned into an image. So on the DLP assembly we have some arrows here, and that just kind of, signifying that the light from the lamp is coming off in this direction. First off, it goes into the color wheel, which is would be this right here. It goes through that little rectangular prism, and that basically kind of acts as like the fly lens that we saw on the other projectors. At least I think that's what's happening. I'm not an expert on this sort of stuff. That's just my observations. We saw that it went through a couple lenses to just kind of focus the light onto that little mirror, which then would bounce off of the other lens that went into the prism. From the prism, internal reflection, bounces off the DMD here, which reacts according to what color is on the wheel at the moment. So if it was green, this the digital micromirror device would reflect any pixels that would require green light. So then once it hits the blue, then the DMD reacts and it activates any pixels that need to be reflecting blue light, and so on and so forth. So the light bouncing off of the digital micromirror device comes out through the prism, and then it hits the projection lens assembly, and then basically that blows up your image outwards. So we can see that the whole kind of like light train, or the light engine here is very simple, due to the fact that all the colors are being produced by the one wheel, and the micromirror device just bounces off whatever it needs to create whatever color you need to see from the image. So then on the LCD, we have our light input coming through here, going through a fly lens, and then that weird like spreader lens and stuff. We have some like a few other optics to just kind of focus the light, and then we hit those dichroic mirror like filters, and that takes care of like splitting the light off into whatever colors they need to be. And then we have a few other mirrors to kind of make sure that the light gets everywhere it needs to go. And then that big prism like block in the center is what takes care of taking all the outputs from the LCDs, which are right here. So we have our blue LCD, our red LCD, and then our green LCD. And I don't think the LCDs themselves actually have any particular color filter on them. I think they just allow the light either through or block it. So they're pretty much monochrome, although they are labeled blue, red, and green. So maybe they do have some sort of filtering on them. I'm not entirely sure. I didn't remove them, but so yeah. So they'll allow light through the pixels. Say right here in the green, they'll allow light for any pixels that need to be green. This one would do the same for the red. That one would do it for the blue. And so if you were to look, if we were to remove the projection lens assembly here out, and you were to look in here, you would see a complete image. You wouldn't even be able to tell that there's individual like red, green, and blue. You would just see, like a full color image right here on this side. Alright, so then the LCOS one, we saw that we have like all of our light, focusing optics and everything over here with that fly lens and all that stuff, and like some what look like UV filtering. So that just comes into this prism here, and then that's the one that takes care of like splitting it off into to go straight, and then another one that bounces off and goes into this direction here for the blue, and then this up here, and then bounces off for the green, and then bounces off over here for the red. So this system here is basically relying on nothing but prisms to bring the light to where it needs to go. But a lot of these prisms are basically acting like the mirrors over here on the LCD. The only problem is that because the light doesn't actually go through these, they're arranged in a way where the light bounces off of them, reflects back, and then it follows whatever path it needs to go to output those particular pixels that need to be like that certain color. So for the blue, they come off here, bounce off this way, and then straight out this way. For the green, they come this way, bounce off here, and then they bounce back, and then straight out that way. For the red, they come here, bounce off here. They basically, the light here just goes straight through, bounces off the red, bounces off that, and then just straight out. And I kind of threw CRT in here just because. So we have our tube. Our image is produced right here on the edge of the. Well, it's on the inside. That's where the phosphors would be. We have our coils right here. Those would be the the horizontal and vertical deflection coils. And then this area here, this cavity, is just filled with the coolant that, and it helps to keep the tube itself cool. This whole assembly here is actually like an aluminum piece, and it has like sort of like few little fins here, just kind of act as a heat sink. And that, yeah, it's just to prevent the tube from just getting way too hot. And then we have our projection lens that's just basically takes all the light output from here, and then that's what blows up the image. And with all that, I think we have finally reached the end of this series. It went on way longer than I had anticipated it, going, but I guess that's the way the cookie crumbles sometimes. So unfortunately, we weren't able to see this thing in action. But like I said, if I can somehow get that ballast board to work, then I'll try to just do like another little small video just on, seeing this thing in operation, and maybe doing some measurements on that dynamic black, and then that smooth picture circuit and stuff. So the whole reason I need that ballast board to work is because I'm pretty sure, and I mean there's some serial communications going on between that board and the DLP board, and without that happening, it just doesn't do anything. So yeah, unless I can get that working, I can't do anything else. So thanks guys again for watching. Remember, if you like this kind of stuff, to subscribe. Hopefully I don't have to do another video that's like another video series that's like this super long again, because it does take a lot of work and a lot of hours like put into this. But yeah, if you like this kind of stuff, yeah, subscribe. And I have a bunch more stuff that I want to do in the future. So once again, thanks for watching. Now see you guys around the bench. We are doing this. Okay, here we go. It even caught on fire. One more time for science. Yes.